So, we are going to get back to it right now. But just to remind you of where I left you, because I did leave you kind of in the middle of something. We had just finished multiplying radicals and doing a quiz on it. I left you here. 30 root 8 over 5 root 2. You don't need to write this down. This is just to get you back to where we were when the bell rang yesterday. And we figured, we guessed, we thought, and we came up with recognizing that if 30 root 8 times 5 root 2 is 150 root 16, because you do numbers with numbers and radicands with radicands, you all guessed, rightly so, that when you're dividing, you divide coefficients with coefficients and radicands with radicands. And of course, the answer to that is 6 root 4, which is, of course, 6 times 2, which is, of course, 12. Yeah? Yeah. Now, that was all well and good. I was very pleased. Everybody figured it out. And then we got to the point where we stopped yesterday, which was when we had something like this. 30 root 8 over 5 root 3. And now all of a sudden, 8 and 3 do not work together. But 30 and 5 do. So this, we got to 6 root 8 over root 3. And there is where we got to. We're just starting to scratch the surface of the next concept, which is dealing with that. Because right now, there is no mathematical need to go further than that. There's none. Back in the day, before everybody had calculators and things, this was a giant pain in the bottom. But it's not anymore. However, the mathematical tool we use to deal with this does become useful later on when your denominators are not just a single thing. And when there are things like variables involved in that denominator. All right? So we got to the point, the general rule is, and again, the rule is simply made a rule arbitrarily. The rule is we do not want radicals in the denominator. I lie. We don't want irrational radicals in the denominator. So to get rid of it, we all recognized that if I multiply root 3 by root 3, the answer is root 3 squared, which is the root of 3 times 3, which is a group of 2, which means it comes out, which means it equals 3. Right? And then we discussed what would happen if I needed to get rid of the cubed root of 3. What would I need as a radicand to get rid of this under there? What would the radicand have to be? 3 squared? 3 cubed, because I need a set of 3 now, yes? Oh, I see. You thought if that was the multiplier. Yes, indeed. Yes, it would have to be 3 squared. So it would multiply together to make the cubed root of 3 cubed. And I think it was this class that I showed that little shortcut to, x root y. To get rid of that, you have to multiply by x root y to the x minus 1. I showed that to you, but I may have used a's and n's and such in there. Maybe. I cannot remember because all three of my 4 classes right now are dealing with this concept. So I can't remember who has actually gotten to a point where they've needed to use this this concept or not. I guess it was you people. Everybody's good? That's where we are now, right? Okay. Slide back over to number C, like all elementary school teachers say, or they did when I was a kid anyway. Have I done that bit with you people? No. Did your elementary teachers ever do that number C? No. None of you? Somebody said yeah. Yeah, Tamano, did you have an old elementary school teacher? No, I mean actually old, not somebody my age that you just think is old because you were 8. Huh? I'm 44. No, it's barely halfway. Average Canadian male lifespan is 78.4 years, which is 39.2 to be halfway. I'm at 44. I've barely passed halfway. I am not living on a prayer, though. I am still not yet, but soon. So, we got to here. Now, does 6 and 5 work together? No. Do 50 and 18? No. So what should we do? Jordy. Yeah, we should break these down. What's 50? Well, I would use 25 and 2 because I'm seeking square roots, right? What would 18 be? 9 and 2. So what's coming out of the top one? 5. What's already out there? So what's the answer? 30 root 2 over 15. What, when I am multiplying and I have the same thing on the top and the same thing on the bottom, what do I get to do? Now, be careful here, because all of you have been taught canceling. So you all grab your pen or pencil and you cross it out and you're like, it's gone, ha ha ha. I am magic. I am the Harry Potter of the math world. I disapparated that root 2. That is not what you did. And the reason I am making a big deal out of this is because next year you are going to be faced with something that looks like you can do this. And I will be teaching you, some of you, and I will say, you can't do that. And you will say, okay. And I will say, do you know why? And you will say, no. And I will teach you. And then I will give you another question that is the same, and you will continue to do the wrong thing. So I'm going out of my way to discuss it right now. These have not disappeared. Because what this blue expression is 30 over 15 times root 2 over root 2. Root 2 divided by root 2 is what? 1. 1 times 30 root 15 is 30 over 15. That is what is happening. They are not disappearing. It is because they equal 1 when you do the division. The reason I'm making a big deal out of it is this. If I gave you x plus 7 over 7, a bunch of you would do that and tell me the answer is x. It is not. Okay? No. It is x over 7 plus 1. Okay? But that is not what we are dealing with right now, so I just wanted to make sure that canceling, you remember, it is not disappearing into the ether. It is actually there, but we just don't write it because it is the same as saying times 1. Just like we don't write the coefficient of 1. Or the exponent of 1. Yeah? Yeah. So yes, we are going to cancel that. And then what will we do with 30 and 15? To get 2. And all of a sudden, this big yucky thing becomes that. Yeah? Yeah. What are you going to do with D? Now that you have seen C, you should all be able to do D. Go. I haven't decided who the problem in the back corner is yet, but rest assured, before the end of this block, one of the three of you is moving. I will be conducting research throughout the next little bit whilst I am teaching to make that decision. Why are all my lights out? Are you happy? Or do we need light? Samuel, hit the top right and bottom left buttons. Nice job. First try, Lego Batman. But really the first try. Huh? I'm aware that a bunch of you would have messed that up, which is why when you eventually got it, I would do the gag from the original Lego movie, where Batman has his Batarang and he throws it 75 times and he finally hits the switch and he goes, first try. Yeah. But that in this case, I actually mean it because he got it on the first try. So, who's taking the magic pen? No, Jordy. We don't have time for that. You've already had your turn. Anybody want the magic pen? Challenge Jordy? I mean, I can go back and show you what it looks like when Jordy does it. Which I'm just kidding, Jordy. I am not making fun of you in any way at all. Actually, I relish the confidence that you bring to the party that you are willing to take the magic pen. Because in all your peers, 29 other of the best and brightest in Math 10, nobody else is willing to risk the magic pen. Except you. You, my friend, are a badass. No matter what anybody tells you. I'm going to write about this on my blog. If any of you blog, I am not making fun of blogging. It is just digital journaling, which is very helpful, as has been proven by millions upon millions upon millions of studies. So what is happening to 60? He waited patiently. Abby. No, it's not fine. Stupid. You could use 30 and 2. You could use 6 and 10. Aha! First try, Lego Batman. See? Why was 4 and 15 the good choice? Raj. 4 is a perfect square. What are we going to do with 27? Who is going to control the magic pen? Raj. 3 cubed, or I would use 3 times 9. Right? 3 cubed works too, though. Now, who will control the magic pen? Back at the blue color. Jordy. I like how you used a magic gesture to make it happen as well. You swished and flicked. Well done.
I'm going to take the 2 out and multiply with 3.
To get?
6.
Root 15. Who is going to then swish and flick to work it down here? That was your swish and flick? Hermione would not be pleased. Better! What?
Then that would be 2 times 3, so 6, root.
Well done. Now, what happens to the 6? It turns into a 1. So do we write it? No. What happens to root 15 and root 3? To become what? Root 5. Does root 5 get simpler? No. Does root 5 have an irrational denominator? No. So are we done? Yes. Excellent. Oh, good gravy. What will happen with E? Now, remember how I said that you wouldn't be seeing that thing that would make you do it? I lied. Because what do you see right here? You see 3 and 3. And how many of you, if I hadn't made a big deal 5 minutes ago, would have gone, enter 6 root 2? Be honest, all of you put your hands up. You would have skipped it. Oh, sorry, I lied. Silly me, Simmer. I forgot to give that as the option. Who would just not bother with it? Now all the hands go up. Okay. Now, here we have a choice, ladies and gentlemen. You could do one of two things. You could do 6 root 2 over root 3 minus root 3 over root 3. Then you would simplify that to 1. And then what is wrong with this side? It's got that yucky denominator, right? So I'm going to get rid of that by multiplying by what? Root 3 over root 3. And I will get 6 root 6 over 3 minus 1. Now what will I do here? Divide to get 2 root 6 minus 1. Right? The other option you have is to deal with this right here, which would be multiply by what? Root 3 over root 3. And then I have to remember that we've reminded ourselves about polynomial multiplication, right? This root 3 has to go there, and where else? There, right? So I end up with, and I'll change colors to green, 6 root 6 minus 3, yes? Because root 3 times 3 is 3, over 3, yes? Now, I see 6, 3, 3. 3 divides into all of that, doesn't it? So I divide that by 3 to get 2 root 6. I divide that by 3 to get 1. I divide that by 3 to get over 1. Do I ever have a denominator of 1? No. So it is gone, and I end up with the same answer. Okay? This is the step right here that a great many of my math students seem to forget because they do not remember that that makes the numerator, I shouldn't have said numerator, that makes that thing a binomial, which is treated differently than if it was 6 root 2 times root 3. That is a monomial because it's times. Okay? Okay. I have a funny story. Oh, sorry, Mantaj, go.
I have a question about the next one. So.
Well, okay then. You go ahead and ask that question.
So for F, what would be divided by? Like, not divided by. So for the second one, you answer the question. The one,
the green way or the blue, or the green way or the black way?
Green way.
If you were going to do the green way here, you would multiply by... Now, what bothers us in that denominator? The 2 or the root 2? The root 2. So we have to get rid of that. We can have a 2 on the bottom, can't we? So we're going to multiply by root 2 over root 2. And then we're going to do the exact same thing we did on this green side, right?
Oh, so if there's a root of the denominator's position, you just multiply by the root to get rid of that?
If there's a radical in the denominator, then that's what you do. But you're going to see something soon that is going to make you not make that your rule, okay? That's the danger of looking for generalizations in math. And it's also why math is a double-edged sword, right? Because how often have I said, if it happens once in math, it always happens? A lot, right? Because math is a pattern. That math, everything on math is based on patterns. So, but the problem is, you people grab a pattern like, oh, same thing on top and blah, and cross it out, and you start to do it all the time without recognizing that this blue thing here is not the thing that you're allowed to do that with. Do you understand what I am saying? Okay. So, here we go. if we go with the green side, where is that 2 going? That root 2 going?
Into the negative 4 root 3 after the 3 root 12.
Right. So what is my numerator going to be once I've distributed that in?
6 root 12.
No. 3 root 24. Radicans with radicans. Minus over. Now this is tricky. 4. Why is it 4? 2 root, and then 2 times 2, 2 root 4, right? And what is the root of 4?
2.
That equals really 2 times 2, which equals 4. Yes?
Yes.
So what I really have here is 3 root 24 minus 4 root 6 over 4. Now what would I do there?
Simplify the 24.
Simplify the 24 because that is 4 times 6. And I would get 6 root 6 minus 4 root 6 over 4. What do I do with that? I combine my like terms first to get 2 root 6 over 4. What do I do with the 2 and the 4? No. Divide. Root 6 over 2. Well, I don't want to beat a dead horse.
First try.
There you go. Connor got you.
No problem.
Yeah? Jordy.
Okay, so I did the exact same thing, and I got the exact same answer, but, I didn't do the exact same thing. I took the whole denominator to root 2, and I multiplied.
Of course. I was just going to say that. Would it have mattered if we kept the 2? What would I have had under there now? It wouldn't have been 2 times 4, root of 4. It would have been 4 times the root of 4, which would have given me 8, yes? And then everything up here would have been doubled. It's just a bigger number to simplify. Okay? Now, the other option, of course, yes, Mantaj?
So, for the step you did, I'm not explaining it. So,
Step 1, Step 2, Step 3, Step 4, Step 5, and Step 6. Where?
for step 4, how did you get 2 root 6 over 4?
Well, we talked about adding and subtracting radicals a couple of days ago, and I used variables, yes? If I had 6 x's and I took away 4 x's, how many x's do I have? 2. Well, I have 6 root 6's. I took away 4 root 6's. So how many root 6's do I have left? 2. Right? Well, I don't know, really.
It made more sense with the X's, okay?
Yes. Sure it did. You have 2 x's. That's enough x's to last a lifetime. Most people would say 1 x is enough x's to last a lifetime. Because she is speaking of x as in ex, as in ex partner.
Or example.
No, because if 1 example was enough to last a lifetime, I could have stopped talking
10 years ago?
20 years ago.
Man, okay.
I wish 1 example was enough for my clients, but it almost never is. Now, of course, could we have gone the other way over here? And I want you to, if you don't want to write it down because you're comfortable with this, don't. But I want you to think about it. How would you split this up so it went down the way we did this side? What would it look like? Caden.
3 root 12 over 2 root 2 minus 4 root 3 over 2 root 2.
Exactly. Now this could tidy up a little, right? Because the 12s divide, so I would have 3 root 6 over 2, right? And this, the 4s tidy up, minus 2 root 3 over 2, yes? Now, they're the same denominator, yeah? Right?
It's a root.
Sorry, yeah, it's a root 2. Thank you. Now, do I have to do any rationalizing here? No, because my denominator is cool. But this needs rationalizing, yes? So I would multiply by root 2 over root 2, which would get me 3 root 6 minus 2 root 6 over 2. And this guy's already over 2, right? Well, 3 root 6s minus 2 root 6s is 1 root 6 over 2. Everybody good? One of those two should be making sense to you. You choose. Okay? This is not a dictatorship about how you do your work. For everything else it is. But how you do your math work is up to you. Turn the page over. What is different about G? The binomial is in the denominator, and they are both radical. Blech! Right? So, we are going to use our brains. What do we know we have to multiply by here? What do we know about this numerator and this denominator over here? What do we know? What have they had to be every single time? The same. Excellent. Okay. Now, what do we got to get rid of here? Root 15 and root 10. So I'm going to need a root 15 and a root 10. Now, I also see I got an operation there, don't I? Right? Okay. So if they're going to be the same like it's been all the way along, math's a pattern, what should I put there? A negative sign. If we are doing that thing that kids do, right? Okay, yeah, it's the same. I got to do the same thing. But is this the same? No, because Jordy explained this is not a monomial on the bottom. This is a binomial, yes? So it's not the same situation, is it? Okay, I want to show you something and you need not write it down. X minus 2 times x minus 2, which is what we're doing right now, yes? Okay. What is x times x? X squared. What is x times negative 2? Negative 2x. What is x times negative 2? Negative 2x. What is negative 2 times 2? Positive 4. Yeah? X squared minus 4x plus 4. Agreed? No problem. Easy peasy, lemon squeezy. Easy as ABC, do, re, mi, simple as however that bad song goes. I don't even remember. You know what? I don't mind that either. That was before Michael Jackson turned crazy. So, now, let's make this root x. So, what's root x times root x? X. What is root x times negative 2? Negative 2 root x. What is negative 2 times root x? Negative 2 root x. And what is negative 2 times negative 2? Positive 4. Tidy it up. X minus 4 root x plus 4. What is wrong with our answer here when compared to the goal that we are trying to achieve? What is the whole point of that multiplication? What are we trying to achieve? What is the whole point? Pardon me? No. What is the whole point of this multiplication? Why are we doing it? To get rid of a radical. Did I get rid of a radical? No. So, obviously, it will not work to do the same thing. Well, what is my only other option for an operation between these two terms? Negative didn't work. Let's see what happens. What is x times x? What is x times 2? plus 2x. What is negative 2 times x? And what is negative 2 times positive 2? X squared. What happened? It's gone. Because 2 minus 2. This is actually gone, isn't it? Because it's 0 x's. Minus 4, yes? So what happens then if I... Oh, this would be so much more impressive if the eraser worked and we could go right to it. If I make this root x and root x, what do I get? X plus 2 root x, negative 2 root x, negative 4. What happens? The radical disappears. So now, take the knowledge that you were able to build from yourself, from your prior knowledge, and apply it here. Will this work? No. So we got to make it plus. Is this still 1?
Yes.
So is it changing the value over here? No, just the looks. Well, we know what to do up top. What do we get? If you can't do that in your head, and because it's math class, I'm actually going to write it out. Because this is where it starts to get not difficult, but complicated. Does everybody understand the difference between those two words? All right? Difficult is performing open heart surgery. Complicated is putting together a 5,000-piece puzzle. Okay? Because putting together a puzzle is easy to do. It's just complicated because there's 5,000 pieces. But you do the same thing every time. You find all the corners, then you find all the straight edges, then you fill in the middle. Of course that's what you do. Lily is going, what do you do?
I just work on whatever I want to first.
I see.
don't start with
Ooh,
the edges.
there's a picture here of a balloon. I'm going to find all the red pieces and make the balloon.
Yeah, by color.
Okay.
Do it by color.
Okay, well, that would be all
And then
wonderful,
once
but
you're
I
all-
once gave my mother a 5,000-piece puzzle that was all yellow. All yellow. Not different shades of yellow, just a piece of cardboard, painted yellow, cut in 5,000 pieces. She had to start with the edges. I also gave my mother another puzzle where all the pieces were the exact same shape. They looked like a gecko, like a lizard, and they could fit together in 5 different ways. My mom was crazy for puzzles. Now she's just crazy. So, you know. Love you, Mom. Plus root 7 times 10, right? Which equals root 105 plus root 70. Easy peasy lemon squeezy. Now, you all already know from over here that the middle term is going to drop out, right? So really, the only thing I need to multiply here is first and last, right? Because the middle's dropping out. So, on the bottom here, what have I got first? What's that going to give me? It's going to give me the root of 15 squared, right? What is the root of 15 squared? 15. What is that going to give me? Minus root 10 squared, which is 10. So now I have root 105 plus root 70 over what? 5. And I'm done, right? Because 105 doesn't get any simpler, because it's 3 times 5 times 7, no pairs. 70 doesn't get any simpler because it's 2 times 5 times 7, no pairs. And I'm finished because I got rid of my radicals on the denominator, yes? Now, this move right here, where you have x plus y, and you multiply it by x minus y, you keep the same terms but change the sign, this is called a conjugate. Don't ask me why. Yeah. So what am I going to multiply here? Now again, you have to use your brain. I know, right? This looks very similar to this, doesn't it? What's different? There's a coefficient. Now, when it was a monomial, did we have to worry about the coefficient? Not if we didn't want to. What do you think's going to happen when it's a binomial? Abby? Okay. What do you think's going to happen? First of all, what do you want to write here? Jordy?
Well, I don't think you need to include the 2, like the coefficient. So all you need to do is add the same thing, but change the operation.
So you think that's going to do it for us?
Yeah.
And I'm not saying you're right or wrong. What is the only way to prove if you are right or wrong now? Try it. What is 2 root 3 times root 3? 2 root 9, which is 2 times 3, which is 6, yes? Okay. What is 2 root 3? Oh, wait. Now, when we dropped out the middle, they were the same, right? Because we had negative 2 and plus 2, yeah? Okay. So let's go all the way through because we're trying to prove a point. So can we skip any steps? Okay. So let's do this one. What is 2 root 3 times negative 2? Negative root 2, sorry. Negative 2 root 6, yes? We're cool, right? Okay. Then the green one. What is green 1? What is root 2 times root 3? Positive root 6. Is it dropping out? Is that going to disappear? No, because I got negative 2, but I'm only adding 1. So what does that tell us? So what do I got to remember that I got to keep if I've got binomials? I got to keep the coefficient. And now I can just do firsty lasty, right? Well, I only have to care about the first and the last one because these are the exact same, right? The middle term is now going to drop out. So what is my new denominator? No, 4 root 9, because 2 times 2 is what I think, and 9 is 3 times 3, right? Minus root what? 4. Okay? I cannot stress this enough. I know all of you are like, Myers, I know root 2 times root 2 is 2. I know. I'm not going to show you that step. That's fine. But I guarantee you, because I have marked thousands of your tests, you are going to do the 2 root 3 times the 2 root 3 wrong if you don't practice it a few times properly. Then I'm going to re-simplify to 4 times what? Which is 12 minus root of 4, 2, which is what? 10. Now up to the top. Do I have to do all 4 up here? Yes. What is the first one? 6 root 6. What is the second one? Minus 3 root 4. What is the third one? Plus 2 root 9. And what is the fourth one? Minus root 6. Now, can I tidy any of that up? I have 6 root 6. What's this? Minus 6. What's this? Plus 6. What's this? Stays minus root 6. Now, can I tidy that up again? What's going to happen at negative 6 and positive 6? They're gone. 6 root 6. Take away how many root 6s? 5 root 6. Now am I done? Why not?
Because 5 and 10.
5 and 10 is a fraction. 1 root 6 over 2. Do I write the 1?
No.
No. Now, please notice you have had to bring radical knowledge, polynomial multiplication knowledge, addition, subtraction, fractions. 5 different topics that you have been taken 9 years to practice are all in one question now, right? That is what is going to happen to you this year, next year, and next year. It is no longer, we just wrote our test on fractions, Mrs. Bad Crumble. I am never going to do them again. Sorry. I just wrote my fractions test, Mrs. Bad Crumble. I'm never going to remember them again. And Mrs. Bad Crumble said, absolutely right. Because that's what it was in elementary school, wasn't it? You did your factor trees in grade 4 and then you never talked about them again. Yes. Yes, I did, Mrs. Bad Crumble. No problem. All right, we good? We good?
We good.
Now, you all said one example was enough.
No.
I know you didn't. On the next 2 pages in your books, you have something that is called an assignment. But the first year I gave it to my honors kids, they were like, tearing out their hair, crying and moaning. So I added the answers and made it not an assignment. Your next 2 pages, but I didn't want to change the title because I love this font, because if you look really closely at it, each letter is a cartoon. Each letter is a cartoon. Let me show you up here.
Has anybody ever complained about their
Only people that don't want to have any fun. See? Each letter is a person. But it's, you can read it. It's obviously says pre-diploma math 10. The font is called caricature. At any rate,
You look like the Ellen
I know.
the giant nose ring.
the giant nose ring on the big nose and the spiky hair.
Yeah, man.
If I were to say any of you look like any of these,
The arm.
I think quite a few of you look like the A often. None of you look like N because you don't smoke pipes. A lot of you look like E a lot, I imagine, when you're doing your math. I look like I because he's a handsome fella. All right.
I'm down to be that one.
So, ladies and gentlemen, H. Where? There's no H even in the word.
Math.
Oh, right. Okay. Back there. I thought you meant on the screen now, Jordy, and I was like, dude, there is no H. That appears to be 2 dudes kissing? I think it is. Oh, no. I'm T. Bald with glasses.
You're not completely
Yeah, just a mouth. That's all Vicky is. Arrgh. Okay. The long and the short of this, ladies and gentlemen, is the next 2 pages. Radical assignment 1 and radical assignment part 2 are due Monday. So you're going to work on it now, tomorrow, and on Monday. Now, if we finish tomorrow, we'll move on to the last section of this unit. Now, the more astute members of the class will have noticed right over here that there is one more lesson than a review. What happens after a review? There you go, first try. That test will occur next week. I do not know what day, so don't bother asking. It will not occur on
Tuesday.
Not Monday.
It will not occur on October 3rd because that would be giving it to you on the first block. And it will if I can avoid it, it will not occur on Wednesday when you have the class last block. Because as everybody knows, if there's any blocks in the day when brains are mush, it is first and last.
Thank you for understanding.
I do understand. Because I too have a brain. And my brain,
How sure are you about that?
dodgy. What?
I think I have a better
Thursday next week.
brain.
It will most likely be on Tuesday or Friday. Now, the problem with that is Friday is a long way from when we've actually studied this stuff. And Friday brains are mush. RJ. Huh? What is the name of tomorrow's day? What is the name of tomorrow's day? So I think you know the answer to that question. I think you know the answer to that question. And I have also already told you that you are going to be working on assignments 1 and 2 tomorrow. Now, am I unreasonable? No. Of course not. Are we heading into a long weekend? Of course we are. Is Thursday the last day of the week? Of course it is. Are your brains going to be accelerated into mush because Thursday is technically Friday? Most likely. So what will I probably do with part of tomorrow's class anyway? There you go. Because I am not unreasonable. However, as always, much as I have told my children throughout their entire lives, not so much now because they're 15 and 13, you do not ask for a piggyback. You are offered a piggyback. You do not ask for game day. You are offered game day. Aight? Abby. No. But my son may go to this school, even though I live in Chilliwack, if I can make it happen.
Why do teachers do that?
Why do teachers do what?
I don't think I've ever met a teacher that had their child go to the school.
Mr. Brar, who used to work here,
Okay, well, maybe
had all of his kids. Mr. Cicchetti's kids go to the school. Mr. DeVries's kids go to the school. I am going, Mr. Lenz's kids go to the school. If my kid does come here, I am going to make him call me Mr. Dad. Actually, I wanted them to call me Mr. Myers, but they were like, I would never do that. It's like, well, then I guess I won't answer you. Dad! You can call me Mr. Dad. No, because, of course, we live in Chilliwack, so they would not go here.